Hey guys, this is Shannon with AVA Direct, and today we're looking at one of the newest X470 motherboards, the second board, and one of the ones we also used for second gen Ryzen testing, the Gigabyte Aorus X470 Gaming 7 Wi-Fi. Now let's go ahead and dig into some of the differences between the existing, as you see here, Crosshair 7 Hero Wi-Fi and this Gigabyte board, because there are quite a few and there's a lot of similarities, as X470 was not a huge change from X370, thankfully. Now, one of the first things I want to preface is we've been using this board for testing, so the plastic mounting hardware that you normally have on it has been changed over to ASUS style, but it comes with the standard plastic mounting hardware. We just don't have it on this board right now. Now, one of the biggest differences between these two boards, between the previous one you saw and the one here now with the Gigabyte X470, is some of the RGB implementation. You have a large light bar here, along with various RGB components, which are all zone controllable. It also has addressable LED support, so you have different zone LED strip support, along with standard 50/50 support, which is the 4-pin regular RGB, non-addressable. So it has support across the board for a lot of lighting options. For those who want to make a big, bright, sparkly case, you can do it. Now, the other thing you're going to see visually is the heatsink difference. This is really important. I feel like Gigabyte knocked it out of the park with this one, because comparatively, while the VRM implementation is way overkill, so a heatsink isn't necessarily even needed, they did something that is just insane, because even in a passive case, this thing would be completely fine. As you can see, they use a fin array, or a stacked fin array, aluminum, similar to what you'd have on an air cooler for a CPU. And you don't see that very often anymore. You only saw it a long time ago. Now they did it here, and that means you have a massive amount more surface area to transfer heat to the ambient air. Whereas something like the Crosshair Hero here has the milled aluminum pieces, so they're very large blocks. And you'll notice that cannot be as thermally efficient, because it basically soaks the heat up, and then the air has to pass by the smaller or lesser surface area to dissipate that. And that's why you don't see CPU coolers made with large chunks of aluminum like this. You more see it with these stacked aluminum fin arrays, because there's so much more tangible surface area you can push heat away. Now, the standard X470 improvements, like the new firmware, the new higher memory overclocking capability, CPU overclocking capability that you get with X470, carries across both these boards. So there's not a lot to discuss there. It's simply a little better. Now, the cool part about this, as I mentioned before, the VRM is insanely overkill, 10 plus 2. So you're talking 10 phases for vCore, 2 phases for SoC or your memory controller on standard Ryzen or Ryzen 2nd Gen, or even your iGPU voltage on your APUs like Raven Ridge or other 7th Gen APUs. Now, there is something really cool that Gigabyte did here, is these two M2s have removable M2 coolers, which means if you have a hotter running M2 drive, or maybe you have graphics cards sitting over it, it's going to help absorb some of that heat away from the controller to keep things running without any throttling concerns for the most part. But if you have, let's say, like a Plextor NVMe SSD, which have, like the M9PE has metal shell over it, you can actually take that cooler off so that you don't impede on the visual aesthetic of that drive. It's really up to how you want to set your system up. Now, as I said, the VRM is massively overbuilt on this board. It's really solid. So I'm going to take a quick break here. We're going to pull all the screws out, pull off the VRM cooler, show you some details on that, along with the specific components on the board itself. Now, with this thing apart, you can see you got a ton of components we're going to talk about here. But firstly, I want to mention that overbuilt VRM cooler. As you can see, it is the fin array like I showed you. It's a direct touch heat pipe directly to this thermal pad, so it soaks up all the heat, any heat actually created by the VRM components, and puts it through this fin array so it can stay easily well cool. Now, the reason I said the VRM is massively overbuilt is the fact that these are 40 amp stages, so that we're talking 40 amps per individual phase. Now, this is controlled by your controller here. It is a IR 35201, which is a 5+2. So that can be a little confusing, because that means technically it's a 5-phase, but it's using 5 doublers. So technically you do realistically have a 10-phase VRM. That's 10-phase vCore, and then your 2 right here, which are your SoC/memory controller. And for APUs, it also controls voltage to your internal GPU. If you have the Raven Ridge, then it controls the voltage going to your onboard Vega graphics, whether it's a Vega 11 or whatever it may be, or even future APUs that may come out down the road. that will be what feeds power here, is these two phases. But this thing being so massively overbuilt means it's going to be in a very good efficiency point when you're fully loading this thing and pushing the overclock. However, it will fall under that efficiency point with lower end chips, things like that, but that's kind of the trade-off you have, because we know a lot of people who are buying the high-end enthusiast board is also going to get the high-end enthusiast chip like a 2700X, where you're going to overclock that thing to what we've seen, 4.2, 4.3-ish, around there. Most of them are around 4.2, and depending on the voltage, you're going to be right around 125 amps or so. So you're going to be pulling a decent amount of power out of these, but it is so well overbuilt that, let's say down the road, since socket AM4, which is right here, where this chip is sitting, let's say the next generation of Ryzen, they decide to up the core count, or one after that. While it's still AM4 compatible, this board could potentially handle the severe loading of a higher core count chip with the existing VRM. So that means you don't necessarily need to build or have a better board built, even though a newer one with better efficiency would probably be available at the time. This gives you upgradability to a higher performance chip should one come. So that's actually really cool as far as this VRM package, because it's going to give you a ton of power capability. And the reason I also had the ASUS board here earlier was just to show how the top end boards are massively overbuilt, because as I mentioned on that board, it has 50 amp phases. Now, that's even more overbuilt, which means when you load that, you're potentially below that efficiency range even under full load. But say a much higher end processor comes out down the road, that one may be in a better efficiency range when that comes around. Now, as far as the audio implementation, Gigabyte's actually done really good over the years of really improving it. And their audio implementation starts with the codec. It is the Realtek ALC 1220, which is very popular, along with a Sabre ES 901-8Q2C DAC. And this is a 32-bit 2-channel DAC. So as you can see, you have your Realtek chip right here. This is your codec. This is what controls where all the audio is going to go and stuff like that. Then you have this, basically, this is an integrated package, this Sabre DAC right here. This is an audiophile grade SoC. So this thing allows you to have basically everything, including your amplifier, all integrated into a single package to make it a better, solid, controllable solution directly out of the gate, and makes it much easier, obviously, to produce because you're putting a single package on the board. And one of the last parts we want to look at is the Wi-Fi capability. Obviously, this has an onboard NIC or an onboard LAN port, which is 1 gig Intel, but you also have 2T2R Wave 2 Wi-Fi implementation. This is integrated Bluetooth 5 along with 11 AC, 160 megahertz wireless. It's up to 1.73 gigabit compatible, but just understand, you need a router to match that to get that kind of speed, but this means you're ready for pretty much any Wi-Fi standard, including exceeding the potential speed of your wired connection at this point. And now you can see why the Gigabyte Aorus X470 Gaming 7 Wi-Fi is a great choice for putting into your newest DIY build or an AVA Direct custom Ryzen build. We have it here ready for you to build into your next badass system, because this thing literally has everything you need for now and even in the future. So if you like this content, please join us on the next one, because we've got plenty of cool new tech toys, gear, gadgets, and all kinds of cool stuff we use in our AVA Direct systems every day, coming to you to show you what's good, what's not, and what we would love. If you're looking forward to some great content coming out of our team here at AVA Direct, please join us on our social media channels such as Instagram, Facebook, and Twitter, and be sure to like and subscribe to this channel so you get notifications when we upload brand new videos to get you the newest in tech every day.